What is meant by a neutral charge? Let's talk about that. A neutral charge is a charge where the number of protons is equal to the number of electrons. We would deem a charge that looks something like this to be neutral. We say that the number of protons is equal to the number of electrons. If that is the case, then we have a neutral charge. Let's look at 7.2. Something to think about. We know that positive and positive repels, and we know that positive and negative attracts. But what happens when you have a neutral charge and a positive charge? What's going to happen? Are they going to attract? Are they going to repel? Or are they going to just be stationary? That is 7.3. Let's go through 7.2 first. So in 7.2, the question is saying that let's state the conservation of charge in words. It says that the net charge of an isolated system remains constant during any physical process. The net charge of an isolated system remains constant during any physical process. That is 7.2. The interesting question, 7.3. Briefly explain how the neutral sphere B is attracted to sphere A. So there we have the answer to the question I had posed earlier. If a neutral charge and a positive charge will attract, they will attract, but now we're supposed to explain why that is the case. Sphere A is positive, sphere B is neutral. Let's have an example of how that can look like. So for sphere A, we can have 4 protons, and then for sphere B, we can have 2 protons and 2 electrons. The same number of protons and electrons. This is positive and this is neutral. What is going to happen when we bring them close to each other? The positive charge will remain as it is. It will remain as it is. Instead of saying N, let's say neutral, because N can also mean negative. So let's say neutral. So when you bring a positive charge and a neutral charge, the electrons on the neutral charge will move closer to the positive charge, while the protons will move further away. This is going to happen because positive and positive repel, right? That is why the protons are further away from the positive charge and the electrons are closer to the positive charge. So what is occurring now here on our neutral charge is what we call polarization. So the positive charge and the electrons are going to be attracting each other because unlike charges attract, but then the positive charge and the protons are going to be repelling each other. But you can see that the distance between the positive charge and the electrons is shorter than the distance between the positive charge and the protons. As a result, the force of attraction will be greater than the force of repulsion. And that is why A and B are going to attract each other. Let's look at 7.4. Calculate the magnitude on the charge of sphere B. What's happening here? Let's go through our equation statement. So in our equation statement, sphere A is brought near the neutral sphere B, and the spheres are allowed to touch each other. Immediately after touching, sphere B moves away from sphere A. Sphere B now has an excess of 20 electrons. So now we have an excess of 20 electrons in sphere B. To calculate the magnitude of the charge in sphere B, we're going to say that Q, the magnitude of the charge, is equal to N multiplied by the charge of an electron. So what is N? We know that we have 20 electrons in excess multiplied by the charge of an electron. That is minus 1.6 times 10 to the minus 19. If you put that in your calculator, you shall get minus 3.2 times 10 to the minus 18 columns. 7.5. What do we have in 7.5? Calculate the charge on each sphere after they have separated. So in order to find the charge on each sphere after separation, we have a formula for that. We say that Q nu, so we have Q nu, which is equals to Q1 plus Q2 divided by 2. Q1 and Q2 being the initial charges on the sphere. So I have a question for you here. Before they touch, we have 2 nano coulombs and 0 coulombs, right? But in 7.4, we just calculated the magnitude of the charge on sphere B, and we see that that is minus 3.2 times 10 to the minus 18 coulombs. The question now is to calculate Q nu. Do we use these 0 coulombs, or do we use minus 3.2 times 10 to the minus 18 coulombs? And why are you saying so? Can you please just let me know in the comments?